Hi everyone, this is Soumya Jain. Today let's start a topic called time and work. This is very commonly used, very commonly appearing topic in various exams for different preparation exam for different exams, I would say. Now, to begin with, let me just start. Have you ever seen this topic or learned about this topic before? So yes, if you remember in class 8th or class 6th, you must have heard of this concept. ये बहुत frequently used concept है. And let me show you how how we used to solve the questions and how the typical questions would have been looked like in the earlier times when we were in school. So a typical question of time and work would look like this. For example, if I say A can do a piece of work in 10 days, B can do the same work in, let's say, 12 days. Now the follow-up question would be, in how many days can they finish the work together? We must have seen these kind of questions across a lot of entrance exams and in the school times also. Okay. Now, first to solve the question. First, let's understand what does this work mean, and let's go back to a bit of history also. How did this come up across? ये concept ही कैसे है? ठीक है. So going to a bit of history about this concept. So this was a concept which has been adapted from the military or army per se, defense forces. So typical example would be, let's say, see, we have, for example, in our case, India has like long borders with India, Pakistan, China, and Burma, and us तरफ northeast में a lot of countries. So we have to man all the borders. Now let's say in particular sector, in particular area, they have to, let's say, construct a fence like this, a wall, let's say a wall like this. Okay. Now for this we definitely need some people to work on it. Okay. And the amount of resources, that is in the sense कि कितने soldiers हैं हमारे पास available, कितने jawans हैं and all that, that's fixed, and everyone is on the guard duty, everyone, some work is allocated. So let's say if I am given the project ki, boss, you have to construct this wall and give us the details. So I go and assess ki what is the length of the wall, okay, and what is the actually what is the work actually. So work consists of building the wall. Sorry, this is the work. Okay. Now if I break it down into simpler things, ki arranging bricks. Basically, building walls is what? Putting in a simplified way, very simplified way, arranging bricks. Okay. Okay. Now, if I go and ask the human resource person, ki, okay, I want to build this wall. Give me money. Give me. I need some people. Then he could straight away say, ki, okay, don't just come out like this. Give us a proper requirement. Ki, bhai, how many people do you need? Okay. First thing, how many people and for how many days will you need? Because they also have to make arrangement. Ki, bhai, if I displace those men to your place, to your site for constructing the wall, who will who will do their work at the where जहां से आप उनको लेके आओ, from where you have brought them, what work, who will complete their work. So they have to make adjustments because they have limited resources. लोग तो बहुत infinite, they are not infinite people, so we are little short on the armed forces people. So how do you do? So in that case, for the better planning, this concept was used. So how was this used? So let's say again here, so work is like building the wall, and if I simplify it, arranging the bricks. Now if I say कि the duration of 1 day's work, I consider ki each soldier, one soldier would work for, let's say, 8 hours per day. And I have, let's say, from prior knowledge or understand from prior data, I can say ki one soldier can put around, let's say, let's pick a number, 200 bricks per hour. Okay, this is, let's say, arbitrary figure. Ki he can arrange or make put on a 200 bricks an hour. So in nutshell, he can put in 1600 bricks per day. How did I arrive at this number? This is nothing but multiply this with this. So this is nothing but 200 bricks into 8 hour per day. Okay. So this is how you arrive at a number. Now let's say if I further make it more go in depth of this concept. So let's say I calculate ki this is the length of the wall, and around, let's say, I have to put across. I calculated ki how what is would be the length of the wall and how many bricks would be required. So I came up with a number. Let's say I want to put in 64,000 bricks total. Okay. So this is the work. Now work is this. I have simplified it. This here from, see, from building just arbitrary saying building a wall. Now I have narrowed it down and quantified it to what is exactly is the work. 6400 bricks. Okay. So this is the thing. Now I have a figure ki one person can put in, one soldier can put in 1600 bricks per day. Okay. Now if I say ki if you give me one soldier, let's say, so this, okay, alone, if I have one soldier, how many days will it take him to complete this entire wall? So that would be what? Total work is 64,000 bricks by 1600 per day. So that will be around 40 days. Okay. Now one soldier can complete the entire work in 40 days. Now I go with the requirement. Okay. To the person who has given me this task, so I ask him how much time do we need to build? Do we need to build this wall? He says, let's say we want to construct this entire wall in 10 days. 10 days. Okay, fine. Since you have to, the timeline has been reduced. So 10 days, if you want to complete the entire work in 10 days, so what does it mean? How many people would you require now? Now, so let's say what they would do is, okay, 6400 bricks. Yeah, yeah. So 64,000 bricks in 10 days. Okay. So per day, how many bricks have to be put across to complete the entire project in this one's timeline? So that comes out to be 6400. Okay. Now I have a figure ki, okay, in one day 1600 one soldier can complete in 6400 1600 bricks. So how many soldiers? That we can be calculated like this: 6400 by 1600. So that comes out to be four soldiers, and that would be completed in how many days? One day, because this is what one soldier can complete, can put in 1600 bricks. So four soldiers can complete 1600 bricks in one day. So this is the requirement per day. So for 10 days, now what has it? What can I conclude? I need four soldiers for 10 days. This is the final requirement that I tell them. Okay, I need four soldiers for 10 days. Now, if I go and tell them, okay, give me four soldiers to complete the wall in 10 days. Now, if I say ki, okay, if they say ki we have more soldiers available, more the merrier. It would be completed before 10 days. If less, then beyond 10 beyond it, the project might go beyond 10 days also. Okay, so this is the concept which has been used, and now we use it across a lot of avenues in our daily life. For example, human resource planning. So they are always, you will see, every project is now quantified in terms of man hours. This is the unit. Yeah, how many man hours do you have? Okay, so this just means ki how many man, how much hours a man can put in, or how much work, the whole work is being broken down to small chunks, and they know, the hiring person knows ki how much work a single person can do in one day. So that is how it is calculated. It based on this number they start hiring also. Okay, this much is hiring has to be done, and they also have a figure ki let's say if they shortlist, let's say 10 people for interview, uh, of late if they only if, like, let's say 6 would appear for the job, who would apply, who would take it to the seriously to the last level. So accordingly, they plan that also ki, to how many people do we need to give a call so that they can join in the interview. Okay, so that's how the planning is done. Now, how we used to solve this question earlier. Now coming to the question, like this one, A can do a piece of work in 10 days and B can do the same work in 12 days. How much time can they finish the work together? Okay, so how this is how that concept is applied here also. And now we'll see how we used to solve it when we were in school. Okay, so what we used to do, we used to write A can sorry, A can complete the entire work, that is W, in let's say 10 days. B can do it in 12 days. So from here, we used to calculate something called 1 day work. And to those who do not remember, or those who remember, this is nothing but we used to do is, if this is 10 days, what we used to do is 1 by 10. This for this 1 by 12. Then what we used to do is 1 by 10 plus 1 by 12. We used to add this. The LCM would be, uh, let's say, yeah, 60. This is 6 plus 5, 11 by 60. And what the answer that we used to get is, we used to inverse it. So this the time taken equals to 60 by 11. Talking about my experience, I did not have a very good understanding of this. I just used to follow the steps. Just whatever this 10 is there, inverse it. 12 is there, inverse that, add them, and whatever the you get, you inverse it again. So that is all. But the concept here was they defined it. The underlying concept that somewhere it's taught and we somewhere it's not taught, but the depth of the concept is that we consider this entire work to be W, and we see ki how much that, let's say, A completes in 10 days. So A can complete the entire work. A can complete the entire work, this W work, in 10 days. So in one day, how much can this person work? That would come out to be, say, by unitary method, which is like this: 10 days W work, 1 day W by 10. Okay, and similarly for B, it would be W by 12. Now in this case, what we were taught when we used to do add the fractions like this, we used to assume that W is nothing but, it was an assumption that W is 1 unit of work. And what we used to do is like this we used to add them. So what is actually done is, we add them. So we used to get, again, if you similar process, we'll add it, W by 12 plus W by 10, we'll get 11W by 60. So this is the work per day, work units of work per day when they work together. Okay. Now this is the 1 day work. That's what we used to call. Now what is the total work that they have to do? They have to complete, the total work is W units. and the rate of doing work is this. So how much days will they take? We divide it. Simple unitary method. So this used to be like this: 11W by 60. And if you simplify it, this comes down to be 60 by 11W. W cancel. This comes out to be 60 by 11 days. That's exactly how what we used to get. So that was the approach. But we were just not told in depth, like how this, why do we do that, and what's the logic behind it. Probably because we were not that developed. We were not that mathematically sound, or at that tender age you don't expect kids to learn that. So a part of that also is key. That's why rote learning works. But never mind. So that was the concept. Now, obviously, this is how we used to solve the question in when we were in school. We can apply the same logic right now also, but the thing is that this would be a bit lengthy. For competitive exams, you need to be very fast. So we shall look into a different approach. That's something which I call it, means this is how I learned from my teachers also. This is called something called brick and wall method. This is just a term, means that's how I know the method. You can search on net. Different methods are available. Different names of the same method are available. So what I used to do is, let's say A completes the entire work in 10 days. B completes the entire work in 12 days. Okay. So what I used to do is, I used to change this work W. I used to assume that the work W is to construct a wall. Construct a wall. Now, how many bricks do we put in? The number of bricks. Number of bricks is nothing but LCM of 10 and 12. Now you would say, why are you taking the LCM? Why is this? So LCM is so that we get basically what we are trying to do is their individual efficiencies we are trying to calculate. How much efficiency means, let me just define this also. Efficiency is nothing but work done per day. That's what, of individual person. So that this number that we calculate is easy, is not very complicated. The calculation is easy, because if you take the LCM of both 10 and 12, they both will be divisible by 10 and 12. The LCM would be divisible by 10 and 12. So that's to make the calculation part easy, we do this. Now, how if we take the LCM comes out to be 60. Now my work again, the work becomes to construct a wall of 60 bricks. Okay, that's the thing. Now, if I say what is the efficiency of A, or the how much bricks does A put in per day? So for A it would be small. I am denoting it by small a. Sorry for this. Okay. For A, it would be puts in 60 bricks in 10 days. So the efficiency would be 6 bricks per day. The short form I am denoting it as B per D. Okay. Now for B, the same efficiency would be 60 by 12, which comes out to be 5 brick per day. Okay. That's individual efficiencies, or individually work done per day by them. Now if they work together, they would be competing the work together. So for A plus B, the combined effort in one day would be 6 plus 5 bricks per day, which comes out to be 11 brick per day. Okay. Now how many bricks do they have actually to put? 60 bricks. The number of days taken by them is equals to 60 bricks in total by 11 brick per day. That's the rate at which they are completing this work. This will come out to be again 60 by 11 days. This method, I am just because I'm explaining you, it looks lengthy, but it's very easy. In fact, using this method, you can solve most of the questions of the same topic of this topic. At a later phase, we will also see, instead of just blatantly putting out ki work done, two people can complete this work in this much days. The same concept is put across in different way of pipes and cisterns. Like two pipes are there, they can fill the tank in this much time. There's another pipe, then there is some leakage and all that. But the same concept applies, completely same concept. So this is what the thing is there. Now let's just solve a couple of small problems so that we grasp the concept even better. Okay. Now let's say uh, this is an example question. So let's say A can do a piece of work in, let's say, 5 days. B can do it in, let's say, 6 days. And similarly, C, another person, can do it alone. This thing is always mentioned. B can do it alone in, let's say, uh, 10 days. Time taken to complete the work together. You have to find this out. Now, again, following the same approach, you can just pause the video and try it yourself using the approach that I've told, or you can just look at the solution. So the solution to this is, again, what we do is see 5, 6, and 10. Now, W is defined as, that is, the work is defined as constructing a wall of these many bricks. Now, the number of bricks is the LCM of 5, 6, 10. What would that be? Now, the LCM would be 60. 60 brick, 60 or 30. Yeah, 30 would be there. Uh, just raise it. 30 brick wall. Oh, sorry for that. So the work would be LCM of 5, 6, and 10, which comes out to be 30 bricks. So the work is to construct a wall of 30 bricks. Okay. Now, if I calculate the efficiency, that comes out to be, for A, it comes out to be 30 by 5, which is 6 brick per day. For B, it comes out to be 30 by 6, which is 5 brick per day. And for C, it comes out to be, again, 10 by, 30 by 10, which is 3 brick per day. Okay. Now, when they work together, obviously their efficiencies would add up, because everyone is contributing their bit to the whole wall construction of the wall. So together, their efficiency, combined efficiency, would be 6 plus 5 plus 3, which is 6 plus 5, 11 plus 14. So together they can put in 14 bricks in a single day. Now, to complete the entire project, how many bricks do they have to put? 30 bricks. So that comes out to be, how many days would they take? 30 by 14. Yeah, 15 by 7 days. So little over 2 days. So that comes out to be 2 1 by 7 days. That's how you solve it. Okay. Now let's take a couple of more questions, different variants of them, and so then we'll solve a couple of other similar questions on the similar basic questions on the similar concept. Now let's say, let me just use the above example again, another variant of it. So we had A takes how many? A takes how much days it is? A second. A5, B6, and C10. Okay. A takes 5 days, B takes 6 days, and C takes 10 days. Now let's say if I say uh, that A and A, B, and C, so B, A, and C work alternatively, alternate days on alternate days, which means in that alternate days in that order. So what does this mean? This means that on the first day, uh, B will come work whatever its efficiency is, it will work with that efficiency. Then on the next day, A will come, it will work with its own efficiency, and on the next day, C will come, and again repeat B A C B A C. This way, in that fashion, they'll come. Now, if they the question asks how much time to complete the entire project. This is what it asks. Now, how do we do this? Now, again, this is just a simple addition of the efficiencies and their contribution. So, as we discussed, so the total work would be again the work would be again a wall of 30 bricks, as we had calculated in the above question, yeah. So this how we obtained this 30 is just nothing but the LCM of the time taken by each of these A, B, C, that is 5, 6, and 10. We are taking the LCM so as to, in order to make the calculation easier. The underlying concept is the same, across. You can take any arbitrary number also. Instead of 30, you can take any arbitrary number. But then the calculation would be a bit tricky. We might end up with fractional efficiencies, which again is complicating the calculation. So to avoid that, I'm repeating that we are using the LCM. So with that, this is what we get. Okay. Now calculating the efficiencies which we had already calculated above, but again let's write them down here again. For A, it is 6 bricks per day. B, it is 5 bricks per day, and for C, it is 3 bricks per day. Just a second, did I make some mistake above? No, that's fine. 3 brick per day. Yeah, fine. Now, how what the order is B, A, C. So for on the first day, second day, and third day. Let's see just these 3 days, first 3 days. Then after this, it's just a repeating. On the first day, B will come, do its work. So how much work will B do? B will put in 5 bricks. Okay. And then the next day, after B comes A. So what will A do? A will put in 6 bricks. And then on the third day, C will come, BAC. So C will put in 3 bricks. So how many bricks have they put in? Total is in 3 days, they have put in 14 bricks. Okay. So in 3 days, they put in 14 bricks. Now, how many bricks? This I can say after this BAC, this is a cycle. In one cycle, they have put in 14 bricks, total bricks that they have to put in. Okay, sorry, this is just a bit space constraint. I'll write it here. So 14 bricks per cycle. So how many bricks do they have to put in total? That is 30 bricks. So number of cycles would be uh, 14, 30 by 14. That comes out to be 15 by 7 cycles. And each cycle has how many days? 3 days. So 15 by 7 into 3, which is 45 by 7 days. Some people might find this a bit confusing. So I'll again explain this again. So what will happen is this. So first day, B, A, C, they come. 5 bricks, 6 bricks, 3 bricks. So again, how many? 14 bricks have been put in 3 days. Now what will happen again? Next day, B comes, then A comes, then C comes, which is again 5, 6, 3. Again 14, 28 bricks put in. Now what will happen? On the next day, 6 days have gone. On the seventh day, B will come in. How many bricks can be put in one day? 5 bricks. And how many are left? 14, 14, 28. 28 gone. Total bricks are 30. So 2 are left. So 2 bricks B will put in. But it won't take the entire day. How much time will it take? Uh, 2 by 5. This is the time that it will take. B can come put in one day. B can put 5 bricks, but it has to put in just 2 bricks, so it will take less than one day. So total 3 plus 3 plus 2 by 5. That is 2 by 5 is 0 0.4. So in nutshell, 6.4 days. Why are we getting a different answer over here? Let me just check. 11 thing 14. 14 bricks in one cycle. And 30, 15 by 7 bricks per 15 by 7 cycles, and each cycle has 3 days. So 45 by 7. So 42, 28, 41, 28, 2. 2 are left. 2 by 5. Some mistake is happening over here. Let me just check. 45. This is 6, 3 by 7. 2 bricks are left, and B will come in. B will take 14, 3 by 7. This is something is mistake is happening. Just a second. 10 bricks per cycle. This is 14 bricks per cycle. 30 bricks we put in 14 bricks per cycle. This is 2 15 are 2 7 are 15 by 7 cycles would take. One cycle consists of 3 days. 45 by 7. 15 by 9, 14, 14, 28, 2 by 5. Seem to be particular something that is happening. Ah, so thing is I am considering how many entire cycles would be required. So here I cannot directly multiply this. Now it is assuming these many cycles would be required. So it is uh, the cycles will are this is one cycle, two cycle, and this is how many days? This is this method cannot be applied because the problem is here it is taking how many days? This one cycle, two cycle, and how many cycle is this? This is what 2 by 5 days by 3 days का एक cycle होता है. So this is 2 by 15 cycles. So the correct way would be this thing, 2 cycles plus 2 by 15, which is, this will have come out to be 32 by 15 cycles. So that's where it is getting. So this, my mistake. This approach cannot be used. This is the wrong approach. The correct approach is this. This is the somewhere. This is how it's getting mixed up. So be cautious of this thing. Okay. Now moving on to the next variant. Yeah. So in this case, like we have seen, BAC. Uh, BAC is the fashion. So first B comes, A comes, and C comes. Now if you see, if we reverse the order, change the order. Instead we put in A, B, C, A, B, C. What will happen? So in this case, this will take again 14 bricks here, 14 bricks here. Now next, how many are left? Two are left. So who will come? A will come. So 14. This is 3 days. This is 3 days. How many days would the B would A take now? So the remaining bricks are two. What is the efficiency of A? That is 6 bricks per day. So 2 by 6, which is 1 by 3 days. So total days 3 plus 1 by 3. So this comes out to be 6 plus this is 9 plus 9 plus 1 by 3, which is 18 plus 1, 19. 19 by 3 days, which is 6 1 by 3. Again, if you see, just by changing the sequence, you have reduced a couple of you have reduced the total time taken to complete the project. And if you do the same for in the another order where you keep C, give C the starting point, then you will see in more days would be required. Because again here on this day, 2 cycles would be anyways required. Here for C it will take C will take 2/3 of a day, 2/3 of a day. So it will take more time. So that is how this problem can be solved. Okay. Now let's move on to a couple of questions on the similar lines. Just a second. Let's say, yeah. So here is the first question, which is A can complete a work in 12 days. And how many days will it take B to complete the same work if B is 50% more efficient than A? Okay. Now you can pause the video and try doing it on your own. Now I'll show the solution so that we have an understanding of the concept. Now let's say in this case we do not have how much A. For A we know it takes 12 days, but for B we do not know. So what do we do? But what's given is key is if the efficiency of A is A, like A bricks per day, the efficiency of B would be, because it is 50% more efficient. So 50% more efficient means A plus A by 2 bricks per day it puts in. So that is 3 by 2 A bricks per day. This is the efficiency of A. This is the efficiency of B that we can assume. If we, when we have assumed that efficiency of A is smaller. Okay. Now in one day, how much can they work? Okay, so first of all, let's define the work. So what is the work now in this case? Now you would be confused that we do not have the parameters. How do we calculate the number of bricks? Fine, it's okay. It can be in the form of an unknown variable also. So A is here. So the efficiency of A we have assumed to be A bricks per day. So it completes the A completes the entire work in 12 days. So total number of bricks is 12 days into A bricks per day, which comes out to be, total work comes out to be 12A. This is the work. Okay. Now, if they worked, how many days will it take for B to complete? So, okay, so this asking for B. Now, this is total work. So, for B, the time taken by B is what? The total work, that is 12A upon the efficiency of B, which is 3 by 2A. If you simplify it, you'll get this. So, A can do it in 8 days. This is one method. Okay. But there's another method also. See, if you observe it, if someone is faster, If someone is faster, it will take less time to complete the entire work. Okay. Now, work is what? Efficiency, that like that we have seen, efficiency into number of days. That's the ratio proportion concept. So if efficiency is doubled, the number of days would be half. So if efficiency is let's say 3 by 2, so number of days would be 2/3. That's the same concept. So for A, if it's A takes A puts in A bricks per day and takes 12 days. For B, it's the efficiency of B is what? 1.5 times. So into 3 by 2. So number of days taken by B would be 2/3 of 12, which is 8 days. Sorry, 8 days. So that's how you can solve this. Whatever method it is, if you are able to apply this concept, it's fine. If you're able to apply this concept, that's also fine. Okay. Moving on to the next question. Again, for every question, do pause the video, try it yourself, so that if you solve it yourself, you'll be able to grasp the concept faster, and then you can check the solution also and see. You might do it with your own approach, but that would be very good, because then the concept would be etched in your brain. You will form a good strong network neural patterns, which will help you apply this concept during the tests also. So that is the case. But anyways, for the time being, just have a look at the solution. So this question says, if 6 men can complete the job in 15 days, how long will it take for 10 men to finish the same job? So six men can complete the job in 15 days and 10 men to finish the same job. Now I will discuss the solution, do the solution, solve this question in 2-3 ways. The first method is, let's say efficiency of men, one man, efficiency of one man. Let's assume this to be A bricks. I'm just putting in terms of bricks only. A bricks per day. So 6 men will put in 6 A bricks per day. Okay. And for in 15 days, 6 men will put 15 into 6A bricks, which is 90 A bricks. This is the amount of bricks. So this is the work. Now we have the work. This is the project that they have to complete. Now what they have asked is, how long will it take for 10 men to finish the same job? Now instead of giving it to just 6 men, they've taken the entire project of making a wall of 90 A bricks to 10 men. Now, and they want to know how much time will they take to complete. It's very simple now. So for 10 men in one day, how much will they put? They will put 10 into efficiency, which is of one man, that is A bricks per day. So 10 into A bricks per day, which comes out to be 10 A bricks per day. Okay. Now what is the work that they have to do? 90 A bricks. Okay. So this comes out to be 90 A by 10 A, which is 9 days. Okay. So that's the way. Apart from that, if you can think of the same thing, key, let's write in this way. So the work to be done is what? Efficiency, or efficiency of one man into number of men into number of days. Okay. Now efficiency of man, this is the constant part, or you can say fixed. These two are the variables that are changing. Now initially it is given 6, and the number of days taken is 15. Okay. Now if I increase number of people, I more the helping hands, the less the time it would take to complete the project. Now what is happening? If let's say this is doubled, so this again number of days would be half. Similarly, if I put it instead of 6, I put it make it 10. So what is happening? What is the multiplying factor? It is I am multiplying by it by 10 by 6. So number of days taken by the number of days would be inverse multiplier, which is 6 by 10. So that way also you can find out. So this would be what? 6 6 by 10 into 15, which is this comes out to be 9. Again, using the proportionality concept. Okay. So that is the case. I hope you are getting the questions and try solving them on your own using both the methods. Anything. And there's no one good method. The only good method for you is the one that you can use to solve in the exams under pressure. That's it. Moving on to the next question. You can pause the video and use solve it on your own. Now this says A finishes the work in 20 days. B finishes it in 30 days. Working together in how many days can they complete? This is a straightforward question. Again, A takes 20 days. B takes 30 days. So W is what? LCM of 20 comma 30, which is 60 bricks. Now they have to make a wall which is of 60 bricks. So the efficiency of A comes out to be 60 by 20, which is 3 brick per day. For B, it comes out to be 30 by 60 uh, 60 by 30, which is 2 brick per day. Okay. In one day, A and B can put 2 plus 3 equals to 5 brick per day. So how many days will they take to put in 60 bricks? It is 60 by 5, that is 12 days. That's how you can solve it. Moving on to the next question. Hmm. This says 15 women can weave 75 mats in 5 days. Okay. And how many mats can 25 women weave in 4 days? Now here, this is again here we don't know the efficiency, but we can calculate. So it says 15 women, 75 mats, 5 days. Okay. Now first let's calculate in one day how much work can be done by 15 women. So if I rearrange it, I will put it again. I'm arrange it this statement again. 15 women, 5 days, 75 mats. Okay. Now I will do what I want is 15 women, one day. How many mats can they make? It's simple. In 5 days, if this is a whole group, let's consider this 15 women a single per unit, a team. So I can say that this team can work for 5 days and make 75 mats. So in one day, how many mats can they make? This is nothing but 75 by 5, 1/5, which is 15 mats. So this is the work done by 15 women in one day. So one woman, one day, how many mats? Again, 15 by 15, which is one mat. So efficiency of one woman comes out to be of one woman is one mat per day. Now, how many mats can the question asks? How many mats can 25 women weave in 4 days? So 25 women one day can make 25 into 1 equals to 25 mats. 25 women 4 days is equals to 25 into 4 equals to 100 mats. So that's the answer. That's how you solve it. Simple. In this case, often it's the efficiency is not easily available, and this is a bit different also because we earlier we used to find out using LCM. By this is the total work, and then we divide it. Here we don't have to do that, but it's concealed in a different way. But again, if you observe it carefully, you can do that. You can easily find it out. This is the way you do it. Just break it down to simple one days, single days, and then single person. You can get it. Similarly, okay, so this is the pipes and Cisterns. We'll see it in a couple of, probably in the next lecture. Let's move on to this question. This is again very simple, straightforward. P can do a piece of work in 24 days, and Q in 36 days. How many days will they take to finish the work together? Again, P 24 days, P Q 36 days. The work comes out to be how much? The LCM of 24 and 36. Sorry, pardon my handwriting. So this comes out to be how much? It's 72 bricks. 72 bricks in total. Now for P, what's the efficiency? 72 by 24, which comes out to be 3 bricks per day. For Q, it comes out to be 72 by 36, which is 2 brick per day. Okay. So together, P plus Q in one day, they can put in 2 plus 3 uh, brick per day, which is 5 brick per day. So how many bricks do they have to actually put in? So total number of days equals to 72 by 5, which is 14.4 days to complete the entire project of putting in 72 bricks. I hope that is clear. So now let's say moving to the next question. Again, this is a similar question that we saw earlier. Try just solving it by pausing the video, and then we'll see it. I'm not actually waiting for you to solve the question. Just you can just stop it at your own end. Now solving this question again, same fashion. 9 children, 5 days, 45 toys. Okay. How many toys can 15 children make in 3 days? So let's first go by days, a systematic way. 9 children, one day. How many toys can they make? Just divide 45 by 5, which is 9 toys. So one child, one day can make one toy which is 9 by 9, which is one toy. So efficiency of a child is one toy per day. Okay. So how many children? 15 children in 3 days. So 15 children in one day equals to 15 toys. 15 children 3 days is 15 into 3 equals to 45 toys. So that's how you can solve it. Again, this is next question is again tanks, pipes and systems. So we'll take it up in the next session. Again, probably this is also I can take this, or I think we can take this in this session also. It's not a problem. Similar concept, 12 machines, 8 days. This question says 12 machines take 8 days to make 800 units. How many machines are required to make 1200 units and in 10 days? So 12 machines, 8 days, 800 units. Okay. So 12 machines, one day can make 800 by 8, which is 100 units. And one machine, wait, just a second. One machine, one day can make 100 by 12 units. That's the efficiency. So what is required? 1200. This is the 1200 units to be made in 10 days. So how many units per day they have to make? From here, you can calculate the requirement for per day would be 1200 units by 10 days, which comes out to be 120 units per day is the requirement. So let's say x number of machines are required. X number of machines, and each machine's efficiency that we calculated is 100 by 12 units. 100 by 12 equals to 120. This is the total that is required. This is how we achieve it. So X number of machines can be found out in this fashion. 120 into 12 by 100. Okay, something seems off. Okay. This 14.4 machines. Let me just check. 12 machines, 8 days, 8 make 800 units. 12 machines, one day make 100 units. Okay, that's fine. It's just the numbers. So 14.4 machines would be required. That's okay. So concept is the same. It's just that numbers could have been a bit more, practical, because 14.4 machines, it's a bit different, difficult to digest. But that's okay. It's just a number. So when they are planning, so instead of 14.4, they will definitely take 15 machines. So they nothing like to 40% of the machine is not there. So that's the case. Anyway, so I hope you were able to grasp the concept, and I have solved a couple of questions, around 10 examples. And so what you can do is just go through the video and solve the questions once again on your own. That will help you grasp the concept and retain it for a longer period. I will in the next session we'll discuss more problems, similar problems in different contexts. For example, as we discussed, pipes and cisterns is something that we will take up in the next lecture. So do watch the next lecture and try solving the questions on your own. And if you have any problem, just contact me, or you can just comment. Thank you. See you soon. All the best.